Hi everyone, today we are looking at lesson 15.2 on page 209, and we're going to start talking about trapezoids. So please have a pencil and a calculator handy as well as your Springboard book. So on page 209, we see that we have this vocabulary word trapezoid, and a trapezoid is a quadrilateral, so four-sided figure with exactly one pair of parallel sides. So we have this one pair of parallel sides, and then these parallel sides are called your bases. So again, here's our parallel sides. And then the non-parallel sides are called the legs. So these two would be examples of our legs. So there's leg 1 and leg 2. And the consecutive sides, the consecutive angles are going to be called our base angles. So in this case, we have our bases, which are going to be, if we call this TRAP, we have bases of TR and PA, two parallel sides. And again, we said the legs are TP and RA. And then we have two different pairs of base angles, right? The first pair of base angle are going to be angle T and angle R. And then we're going to have a second pair of base angles, which are going to be P and A. So angle P and angle A would be the other pair of base angles. Those are the consecutive angles. The median of a trapezoid is going to connect the endpoints of the midpoints of each leg. So very similar to our mid-segment of a triangle, the median is going to connect the midpoint. So M is a midpoint of FE, divides it into two congruent pieces, and then N is a midpoint of GH, divides it into two congruent pieces. And the trapezoid median theorem says that the median of the trapezoid is parallel to the bases. So here's our bases, which are going to now be parallel to that median, and its length is the average of the lengths of our bases. So basically what we can do is add up the two bases and divide by 2 to get to the length of our median right here at N. Okay. So using that information, we have that same figure now we are using on page 210. You definitely want to draw this picture in your notes so you can follow along. Now they're telling us in part A that GFE, this angle right here is 42 degrees. And we now want to know what is NME, this angle right here, and then eventually MEH. Well, NME, it's important here to note that we have a median here. And the reason that's important is because we know all these lines are parallel. And if the lines are parallel, we know that these two angles are congruent, because I know it's been a while since we talked about this, but they are corresponding angles, right? And the corresponding angles are congruent when our lines are parallel. So this one would also have to be 42 degrees. Now, MEH is this angle right here, and that would be actually same side interior to our given angle. So we know that those are supplementary. So that would have to be 138 degrees based on that relationship. Okay. Now in the next piece, they're talking to us about some side lengths. Again, notice there's no angle symbol. We know we're talking about sides. And they're telling us that FG is 4x plus 4. EH is x plus 5. And the median here is 22. And we want to know what is the value of x. Well, if you remember from the previous page, we know that if we are going to solve for the mid-segments, we have to add up our two bases. And if we divide that value by 2, aka multiply it by 1/2, those two values added together and divided by 2, aka the average, is going to equal our median. So to undo this division by 2, we can multiply both sides by 2 to start here. And we end up with 44 on the right-hand side. And then we can also combine some of these x's and constants to help simplify as well. Now subtract 9 and divide by 5, we get x to be 7 here for part B. Now, a little bit easier than that is if they did not give us algebra to do on this particular problem. If they gave us just side lengths, we have MN is 19, EH is 12. And if we were looking for FG, again, we know that 12 plus FG, again, divided by 2 or multiplied by 1/2 has to equal our median. So if we multiply both sides by 2 to get rid of this value here, we get 12 plus FG equals 38. And if we subtract the 12 away, FG would be 26. Okay. All right, now down here for 5 and 6, just a couple other things about trapezoids. How are they different than the kite, in which we talked about last lesson? Well, a trapezoid has 2 parallel bases. A kite does not have a pair of parallel sides, unlike the trapezoid. And then in number 6, it says, can a trapezoid have congruent bases? The answer is no, because otherwise the figure would be a parallelogram. Now, our trapezoids can also be considered isosceles. And by definition, an isosceles trapezoid is a trapezoid with that pair of parallel bases that have a congruent pair of legs. So the 2 legs here are congruent or equal in length to one another. So using that information, if we look at the next page, there's a couple other things you want to note, either highlight or star in your notes about these isosceles trapezoids. Their base angles are congruent. Okay, so what that means is if we have an isosceles trapezoid, due to this parallel nature and the fact that these are congruent sides, we know the base angles are congruent. So these 2 would be congruent to each other, and these 2 would be congruent to each other. So if we go back to TRAP, we would be able to say that angle T is congruent to angle R, and angle P is congruent to angle A. And that's due to the fact that these are in an isosceles trapezoid. Okay. The other big thing to note about isosceles trapezoids are that their diagonals are also congruent. Okay, so if we drew in the diagonals here, they would equal each other, right? If we went back to calling this TRAP, TA, the first diagonal would be congruent to PR, the second diagonal. Okay. Now, finally, again, we have some vocab here that we've talked about. We want to use some of this information about isosceles trapezoids. So in this picture here, they're telling us that this is an isosceles trapezoid. So we want to make sure we mark it so that we know those properties hold true. LPN is this angle right here. Well, we know it's congruent to the other base angle, angle L, or in this case, we would call it PLA, to better name it since there's a couple different angles at angle L. And what we know about that is if that angle is 70 degrees, like they're telling us in part B, then we know that LPN also has to be 70 degrees because they're congruent to each other. Now, the other pair of base angles, however, PNA and LAN, they're supplementary because, again, they're same side interior angles. Remember, same side interior angles are supplementary, okay, to each other. So that means that these other 2 angles, angle PNA and angle LAN, the big angle N and the big angle A, have to both be 110. Okay. Now, the other piece of this, I'm going to erase this so we can see it a little bit better, is asking us to look at AP and NL, aka the diagonals. Well, from the last page, we know that the diagonals are congruent, so we can set them equal to one another in order to solve for x. So if we add 8 to both sides, subtract a 2, x is going to equal 4 for this problem. Okay. So we will talk more about this quadrilateral family tree in class, but if you have the ability to print this out or write it in a notebook, I highly would, okay? So to kind of summarize for today, we have these quadrilaterals, these four-sided polygons. And one of the branches we now have to talk about are the trapezoids, right? And our trapezoids are going to have one pair of parallel sides, all right, inside of them. Specifically then, our isosceles trapezoids have their legs congruent and their diagonals congruent. Their upper base angles are congruent to each other and their lower base angles are congruent to each other. And the upper bases are going to be supplementary to the lower base angles. And of course, just like the trapezoid, it has the one pair of congruent sides. Okay. So thanks everyone for listening, and we will work more with trapezoids in class.